Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Well, good evening, everyone, and welcome to the Event Horizon here on Astronomy.FM radio. It is another Friday evening. This one is March the 16th, 2018, about 9 o'clock in the evening for those of us here in the eastern portion of North America, and that is daylight savings time, by the way. Universal time would put that at 1 o'clock in the morning, March the 17th, 2018. My name is Marty Kunz, and my co-hosts are...
Hey, everybody, it's Starstorm.
Welcome, Starstorm.
And of course, it's me, Nick Evetts. And what are we going to do, everybody, on Friday night? We're going to
take over the world!
Yeah, we could do that. How's everybody doing tonight?
Oh, I'm peachy. How about you, Starstorm?
I'm good. Just try not to cough on audio.
That's okay. I have clear skies. I don't know about you guys, but I finally have a nice clear night out tonight.
It's patchy cloud.
Is
yeah.
it? Too bad. I didn't get a chance to get out though, but there is really great opportunity to see Venus and Mercury just after the sun goes down tonight. And Mercury just passed greatest eastern elongation. That means it's farthest distance from the sun in right after sunset. I haven't seen Mercury yet, but I have seen Venus, and Mercury will be getting back close to Venus pretty soon. And we'll go over that in just a little bit. So nice to have some clear skies. And this is a new moon weekend for all of you deep sky observers out there.
And if you're looking at looking west, and for Venus and Mercury, you will see a very, very thin crescent moon.
Oh, that's true.
So
I forgot about that. I should have gotten out tonight.
No, I hadn't forgotten. It's now more likely you probably may see it in the twilight on March the 18th. This is the image I'm being told. So you'll have Mercury slightly to one side of Venus in the middle, and on the other side you'll have a very, very thin crescent moon. So this quickly scanning down here. This is saying it's for March the 18th. Twilight fades look due west for Venus with the super thin moon 3 to 4 degrees to its left, as shown. Let me put the link. Oh, let me put the link into chat.
Put the link in the chat.
Yeah, give me somebody to put in the show notes.
There you go.
There we go. Okay, so we jumped a little bit ahead with the moon, Venus, and Mercury. So, you know what? I'm going to kick off with Friday, March the 16th. We'll let Starstorm take the 17th. And we'll take it from there. So, the biggest asterism in the sky is, of course, the winter hexagon. Right after dark in March, it fills the sky towards the south and west, starting with brilliant Sirius in its bottom, nearly south, going clockwise from there, March, upper left through Procyon, and then up to Pollux and Castor, near the zenith. Then head to the far right through Mycelanen and to bright Capella. Then lower to Aldebaran, further lower to left to Rigel, in Orion's Foot, and back to Sirius. Betelgeuse shines inside the hexagon below center. In a few weeks, as the constellation wheels westward and the hexagon's lower half sets, its top half becomes the twilight arch of spring.
Who's next? Go ahead.
Saturday, March 17th. Spring begins in 3 days, so watch the low east northeast tonight for the rise of the spring star Arcturus. Find the Big Dipper high in the northeast and follow the curve of its handle down around by a little more than a dipper length to see where Arcturus is, or soon will be. New moon is at exactly 9:12 a.m. Eastern Daylight Time.
In the southern hemisphere, which we haven't done in a long time, we'll start doing that. We've got 47 Toucan, and Caldwell, I think it's 134. Sorry, 106 in the early evening skies towards the southwest. So that would be starting to head down there. Canopus is high overhead this time of year, and so we're starting to lose the small and large Magellanic clouds towards the west.
Okay, Sunday, March the 18th in the northern hemisphere. As twilight fades, look due west for Venus with the super thin moon, which I've already gone to at the beginning of the program. Now, look for Mercury, much fainter at magnitude plus 0.4, sorry. Thank you. By nightfall, the constellation of Ursa Major is high in the northeast and beginning to tip left. Look well to its left for Polaris and the dim Little Bear or Ursa Minor. Other than Polaris, all you may see of Ursa Minor through light pollution is the two stars forming the outer edge of its bowl, Kochab, similar to Polaris in brightness, and below it, fainter Pekahad. Find those two guardians of the pole to Polaris's lower right by about a fist and a half at arm's length. Now is the time of year when the guardians line up vertically, exactly at the end of twilight.
Go, Star Store.
Monday, March 19th. If the crescent moon were a bow, it would shoot an arrow to the lower right, just past Venus in this evening's twilight, as shown above, if you're looking at the website.
There you go.
Go
ahead.
After dark, Sirius shines brightly in the southwest. Lower left of Sirius by about one fist is the triangle of Eldera, Wesen, and Uldra from left to right. They form Kansas Major's hindfoot, rear end, and tail, respectively. Just left or upper left of them, forming a third and fourth magnitude arc, are the three uppermost stars of the constellation Puppis. No, it's not a pup, despite its nearness to the big dog. It's the poop deck stern of the giant ancient constellation of Argo-Navis, the ship of Jason and the Argonauts. These three stars are the only ones of Argo that are readily visible naked eye from mid-northern latitudes.
I think I'm next. Watch from the southern hemisphere. Watch Capella, slightly above the northern horizon, not staying up very long, and then heading down below the horizon. So kind of barely a glimpse of the mostly northern star Capella. Castor and Pollux hover around the northern horizon, along with Persepi M44, and the former asteroid, now dwarf star Ceres, which we'll talk about a little bit later on what's happening on the dwarf planet Ceres.
Okay, so March 20th, Tuesday. Today is the equinox at 12:15 p.m. Eastern Daylight Time. The center of the sun crosses the equator, both Earth's equator and the celestial equator, which Earth's equator defines. This moment marks the beginning of spring in the northern hemisphere and autumn in the southern hemisphere. And no, eggs don't balance better today than at any other time. After dark, Leo strides up in the eastern sky with his rising star Regulus in his forefoot, and the sickle of Leo extending upper left from there. About 2 fifths lower of Regulus to the left are the two stars of Leo's rear end and tail, Delta Leonis, magnitude 2.5, and below it, slightly brighter, Beta Leonis, or Denobula, the tail tip, magnitude 2.1. As the evening grows late and this scene rises higher, look left of Denobula by a fist or more, perhaps, for the big dim Coma Berenices star cluster. Its brightest members form an upside-down tilted Y. It's visible through some light pollution. If you can't see it naked eye, binoculars will reveal it well, looking rather ragged and more or less filling the field of view.
Wednesday, March 21st. Upper right of the crescent moon this evening, you'll find the Pleiades. Upper left of the moon are Aldebaran and the Hyades.
Mm-hmm.
Do you know how to find the horn tips of Taurus, Zeta, and Beta Tauri? One way is to extend the size of the Hyades V way up by about a fist and a half, as shown in the diagram on the website. But another way uses brighter stars. Spot Betelgeuse high in the southwest these evenings. It's Orion's topmost brightest star. Then look high in the northwest for Capella, even brighter. The horn tips of Taurus lie halfway between them, lined up with them. Beta, on the right, is the brighter of the two.
All right, did we get through the week?
Oh, we've still got Thursday to do, mate.
Ah, okay, go for it.
Okay, Thursday, March 22nd. Aldebaran pairs closely with the moon this evening. Castor and Pollux shine together nearly overhead in the south after dark. Pollux is slightly the brighter of these twins. Draw a line through Castor, through Pollux, to follow it further out by a big 26 degrees, about 2.5 fist widths at arm's length, and you're at the dim head of Hydra, the sea serpent. In a dark sky, it's a subtle but distinctive star grouping, about the size of your thumb and an arm's length. Binoculars show it easily, although through light pollution or moonlight. Continue the line further by another fist and a half, and you hit Alfred, Hydra's orange heart. Another way to find the head of Hydra is almost midway from Phocyon to Regulus. And of course, we'll bring you Fridays, the 23rd, on Friday the 23rd.
Sounds good to me.
Me too.
You know, one thing you could say about balancing an egg on the equinox, well, eggs can be part of a well-balanced diet.
Absolutely.
There you go.
And if you make eggy bread, it's even better.
There you go.
Sorry, I had to get that one in.
And,
Okay. Now, we know that we lost Stephen Hawking's CBE this week.
Mm-hmm.
What people don't know is that he actually took part in an iconic BBC radio show. He's actually taken the role of the Hitchhiker's Guide to the Galaxy Mark II. I put a link into there. It's the hexagonal phase, one of 6 episodes. And of course, Stephen, being Stephen, obviously couldn't resist the chance to take part in a good bit of malarkey, like the Hitchhiker's Guide to the Galaxy.
But it's a fun thing to listen to.
Absolutely, and he does it so well. And there's a couple of links I have seen, I'll have to find again, and I'll post later in the show, where he is the voice of Deep Thought. And of course, we all remember him playing cards in Star Trek The Next Generation. And I'll just put a link into that for you later to look at, where he's playing with not only just Data, but also Newton and Einstein.
Mm-hmm.
So as I say, he's always been a man who's enjoyed having a little bit of fun with science. And I think that's probably one of his greatest attributes, that he had a sense of humor. Of course, some of us will remember his perhaps infamous bet with Leonard Siskin about black holes. Of course, he lost the bet, and he kept his side of it, and he bought Leonard the subscription he requested. I don't think we can go into what it was, as I remember. I don't think that's quite family friendly to name that magazine.
Mm-hmm.
But anyway, he was a good sport, and even though he lost, it was good fun. Now, I know we forgot to do it at the beginning, so I'm just going to say welcome. There's myself in the chat room. There's Marty, Starstorm, Selby, Glenn, Black Projects, Red Shirt 3. Nice to see you. Missed your company. Aqua for you, and Uptronics. Welcome, guys, and glad to see you here.
Yep. Glad you're in tonight.
It was a nice room tonight, yeah.
Mm-hmm.
Always much fun when we have a good audience that we can bounce off.
I know.
Oh yes, most definitely. So, been an interesting week. Now, there was a story I meant to cover last week, and I completely forgot about it.
All right.
But I'm just pulling up the story right now. Hubble has detected or discovered a very unique type of object in the solar system. Now, thank you for Starstorm. Thank you, Starstorm, for the links for SpaceX, NASA, and ESA in the chat room. So,
I try to put them in there.
Yep, that's always appreciated. So I'm just going to pull up the link myself. Now, there's a pair of interesting objects With the help of NASA Space Telescope, a German-led group of astronomers have observed an intriguing characteristics of an unusual type of object in the asteroid belt between Mars and Jupiter. These are actually two asteroids orbiting each other and exhibiting comet-like features, including a bright coma and a long tail. Now, this is actually the first known binary asteroid that can also be classified as a comet. And the research is presented in a paper published in the Nature journal, and that was back around March the 8th. Tavi gave me the story, and I apologize, Tavi, I completely forgot about it last week's show.
I'm sure.
So, what happened was, back in September 2016, just before asteroid 288P made its closest approach to the Sun, it was close enough for the Earth for astronomers to have a detailed look at it using the Hubble. Now, the images reveal it's located in the asteroid belt, as we said earlier, between Mars and Jupiter. And it's not a single object, but it's two asteroids of almost the same size and mass, orbiting each other at a distance of about 100 kilometers. In itself, that's an important find. A, because they orbit each other, and B, the masses of the objects in such systems can now be measured. But it also revealed ongoing activity in the binary system. There has been a lot of thoughts. You're welcome, Brescia. Always glad to have you in. That the fact is that sometimes what appear to be asteroids suddenly turn into comets. Mm-hmm. There was a lot of thought that maybe these were actually maybe dead comets that have been woken up by some unknown mechanism and started to give off dust again and produce tails and a coma. So, the really interesting thing is, it's the first binary asteroid that's been classified as a main belt comet. Now, we don't really understand the origins and the evolutions of these main belt comets yet. Comets that orbit between the numerous asteroids in that very complex and packed area between Mars and Jupiter. It's a crucial element, really, in understanding our formation of the solar system and its evolution. So amongst the questions these comets can actually help answer is how water came to Earth. Since only a few objects of this type are known, 288P presents itself as an extremely important system for future studies. And as I say, a lot of us have really thought that there are about two or three comets that really bear investigation. Yes, some of us would like a long-term space mission to 29P, SW1. Our good old friend Schwackman, and I always get that wrong. Deal with it, Marty. And the other one, of course, being sending a long-term probe to Halley's comet. So perhaps encountering it still in the outer solar system, following it through perihelion, and following it back out. Because it would be very interesting to see how the comet changes as it approaches the Sun close up. Mm-hmm. We've only had one probe visit it. That was Giotto, which went on to Greg Skellerup afterwards, even though the main camera was damaged during the Halley's nucleus encounter. The rest of the satellites systems were still very functional, and of course the probe had fuel, so it was retasked. And Aqua for you is saying we need a new comet, a bright one, please. Well, the thing is, we may get that. I'm saying may. At the moment, there's not very many candidates out there, and I am keeping my mouth shut on that, because comets are like cats. They have tails, and they do exactly with them as they wish. And for me to say, oh, so-and-so comet's going to be a bright comet is really pushing my luck, and I know better. And I'm pretty sure that Eugene Shoemaker would probably jump out of his grave and slap me one for that one. And I know David Lee.
I had a feeling this picture of this comet is an artist's conception, though. Is that true?
Looking at it, I would agree with it.
I would assume so,
it doesn't look like what we used to from the Hubble.
Right.
The Hubble gives us. Mm-hmm. Now, for some reason, they're not publishing the images they're using, probably because, A, there's ongoing science. We have noticed since Rosetta that some scientists really love keeping their science to themselves until they've done what they want to do with it, and then they release it to the general public. Yes, Glenn, you do that. I do not feel sorry if Bubba gets you, mate. Hayataki would be good. It came out of nowhere and it brightened within a month. Yeah, that could be a possibility.
Mm-hmm.
But we know that we have perihelion for Halley's Comet around 2061. That does give us a chance to send a probe out there. And given the technology we have now for ion drives, it means it could maneuver and keep itself out of harm's way if necessary. Of course, always the big issue with these missions has always been carrying enough fuel.
Mm-hmm.
Now, New Horizons, and other probes recently sent out have had this drive, and it has been tremendous because it's allowed scientists a chance to change altitude and location, particularly with Ceres, and it certainly has allowed us to go from Pluto into the Kuiper belt and look at some a trans-Neptunian object that is very, very much fresh, so they say.
Mm-hmm. Have you seen the Facebook stuff going around Facebook about the asteroid Bennu?
No, I haven't actually.
It's I don't know why it's
all the
just
groups I'm in. We squash and delete idiot posts like that.
I know. Yeah, it's been around. It's been going around more recently about the potential of this asteroid of crashing into the Earth in 2135, I think it is. Yeah, and the big thing is that NASA can do nothing about it. It's like, yeah, 110 years from now, and we're going to have the same technologies now. I don't think so. And this rock is not really that big, so. Yeah, maybe NASA can't do anything about it right now because NASA doesn't have any big rockets, okay? So if we just get, 100 years more technology, a lot of rocket companies building rockets, this rock is not that big. Now, if you've seen all the asteroid collision pictures where, the rock is like splashed the atmosphere and the ocean away, and it's about, almost a quarter of the size of the Earth. No, this rock is about 1,500 feet. When they depict it, I've been looking at it, they've been depicting it as about 1,500 miles in diameter. It's not 1,500 miles in diameter. It's 1,500 feet in diameter. So that's actually a small, small rock. In fact, if it was sitting on the ground, you would not be able to see it from orbit. It's that small.
Well, that was one of the reasons they chose it for OSIRIS-REx.
Mm-hmm.
It's nice, it's small, and we have a very positive track on the orbit,
mm-hmm.
which means we are going to be going. We're going to attempt to land a space probe on it.
Mm-hmm.
They are talking about using a harpoon system to anchor it. They are going to take a rock sample, mm-hmm. and they're going to bring it back to Earth. Now, if they could have done that with Rosetta, I could guarantee people would be fighting
mm-hmm.
to see the sample. Mm-hmm. It would be like back in the days of the Apollo program when the first moon rocks were brought home by Armstrong and Aldrin. People would queue to get a glimpse at a batch of crumbly-looking rocks, which actually were extremely ancient in reality. Mm-hmm. Probably slightly more ancient than what we have available still on Earth. As I say, I'm not really worried about Bennu because by the time 2061 or whatever comes around, space travel will be far more advanced,
mm-hmm.
and if it hasn't, we're probably dead by then anyway as a civilization.
That's true.
We got to look after this beautiful pale blue dot.
Well, we might have colonies on Mars.
There is that possibility, yes. Musk has got his BFR, his big freaking rocket, as he calls it. I'm sorry, I actually laughed so hard when he described it that way. He was like the kid in the candy store. He hasn't even, at that point, he hadn't even got the heavy Vulcan off the ground, and he's already moving on to something like the Anastasia from Dan Dare.
Mm-hmm.
You know what? It amazed me. This guy just does not take no for an answer.
Well, isn't that a good thing?
Absolutely, it's a great thing, Starstorm, because he has the vision and the drive to want to succeed. You know what? At the end of the day, the idea of commercial companies building rockets is a great idea, because they will definitely help drive exploration of the solar system. One of the things I really want to see is I want to see Orion being launched by Heavy Falcon.
Mm-hmm.
That would give NASA much more flexibility. SLS is brilliant, but as I say, this is already behind schedule, and Boeing needs to be ramping up and producing much more rocket units than they are now. The Apollo program was looking to build at least 4 or 5 rockets a year, just to give them the enough inventory to go and do what they wanted to do. They wanted to do unmanned tests. They did the first manned tests. They did all the missions, A through F, F being, of course, Apollo 10. And there's an interview coming up after the show tonight. I actually had a chance to catch up with Nick Howes and have a chat with him about Project Snoopy. We'll go into it more there, okay? But do stay listening after the show, because it is about 24 minutes long, but we had a good chat about what's going on with Project Snoopy, and I think you'll be quite happy to hear what's going on with that. And we touched on a few other things and had a good giggle together. We're both the same type of guy. We're both geeks. We both love space rockets, and we love the way things are going. Did Dan Dare influence Musk? I really hope so, because what he's doing, his BRF really does look like the Anastasia, and that really made my day. I just wish the old man could be around to see that, because he got me into Dan Dare. He gave me an old Eagle Annual, I think when I was 7 or 8 years old, from the 50s, and that was it. I wanted to know. I was reading up on rockets. Apollo 11 came along, and I had my first telescope, and as I say, the rest is history. And now I'm here.
And on the dark side of imaging.
Absolutely. The best thing about the dark side, we have CCDs and hot chocolate.
There you go. What I like about those about rockets is lighting the fuse and see how far away it can get, before it takes off. Now with the big couple 100-footers, it's been a bit of a challenge. A couple extra layers of clothing on them, but yeah, it's fun that way. Speaking of rocket launches, there is one coming up Wednesday, March 21st. It'll be Expedition Crew 55 launching to the space station. Of course, that would be from Russia. 2 days later, the Soyuz will be docking to the space station itself. So you've got 2 days to be able to see them fly near each other separately. Well, it's going to take a while for obviously to catch up. But so as you get closer to Friday, March the 23rd, it's supposed to dock at about 3 in the afternoon, our local Eastern Daylight Time. So somewhere around there, try if the space station is over your area at nighttime, you might actually be able to see them separated and then get close into docking. So that's a project I've been wanting to do for quite a while.
See, one of my friends at Northolt Astronomy Group actually does image the ISS, and he images, he tries to image when the cargo ships dock there and everything detach and come home. I think it's Salzburg's, but as I say, he's in the Northolt group. If you're a part of the group, check out his work. He's got some really cracking good images of the ISS, and he actually, when it's difficult to make out the Dragon capsules, he will mark them on his pictures for
nice.
Now, the other thing I wanted to say, Red Shirt 3 made a good point. Aquifer, you said, why can't we use old ICBMs? We've used all our Titans up. Titan was actually the mainstay of Gemini, Mercury and Gemini, and we actually used weapons. We turned weapons of war into instruments of science. The Agita was built from missile technology. The docking module they used for Gemini was built from literally a piece of kit designed for war. which was one of the greatest things about it. We're taking weapons of mass destruction and we're turning them into scientific equipment. So as I say, it did happen that way. We used them all up, and unfortunately they're no longer available. The Delta, I suppose you could describe the Delta rocket as the ultimate descendant of those early ICBMs that we were using, NASA were using for launches. Now, whether or not a heavy Delta can do it, I don't know. But who knows? We may find out eventually once, of course, Orion gets delivered. And the nice thing about Orion is the command capsule section is made in the US. The command module, the part that can also be left in orbit, is being made in Germany at the moment.
Nice.
So it's a nice international effort, which I really think is the way it's going to go forward. Eventually, I would say we would see someone like Musk, maybe Bezos, partnering with space agencies in Europe and the US, and maybe even with Japan, to have launch facilities both in north and southern hemispheres, where you can actually do a manned launch, and have an availability 24/7, 365 days a year. The really great thing, of course, is everybody sat down and said, "Oh no, space will never be commercial. Space will never make money." I'm sorry, Musk would never be doing it, unless it was making him money.
Now, who said that and when?
Want to use a Soyuz for a trip to Mars? No way, too cramped and too ancient.
Who said space will never make money, and when did they say it?
Well, that was one of the big things that were being said against Musk's vision for Falcon. No one ever believed that a commercial company would make money out of doing launches. And Musk is making money. He wouldn't be able to fund Falcon Heavy, and he certainly wouldn't be funding
launches, period.
Yeah, launches, period. And of course, the BFR is being funded out of launches with the standard Falcon 9 and Falcon Heavy. So he's put a whole load of Falcons, the lightweight Falcons, to one side for people who prefer them. Falcon Heavy is coming in. Falcon Heavy will soon, hopefully, be man-rated. And once that happens, I'm corrected, it's a service module. Thank you, Red Shirt. It's being made in Germany. But you know what? This is what space exploration is about. No one country can do it alone. If you look at how much of the US GDP was used back in the 60s to put man on the moon, it was a tremendous amount compared to today. Basically, if you look at your tax bill, pennies from your taxes go to NASA. And at the end of the day, they're being badly underfunded in my book, and also they keep being turned around and given new directives. So how are you going to get anything done? Some people are saying they should ditch SLS and do a ramp up on one of the earlier systems that was brought in by the Bush administration. Well, that's not going to work because you've got to get all the tooling back. You've got to rehire or retrain everybody to actually build the thing. So probably the best thing at the moment is to fund SLS properly and fund NASA's other modules, which is the robotic science missions, equally as well, because they are providing us at the moment with our view of outer space, of the solar system. And at the end of the day, if we lose those eyes in space, we won't get the information we need for manned missions into the further reaches of the solar system. I know, I'm getting on my soapbox again, ain't I?
Mm-hmm.
But you have to think, there are companies who will pay to put their satellites in space.
Yeah, people are willing to pay. Originally, you had to pay NASA.
It's just a matter of how much.
Yeah, but Musk is undercutting them.
Mm-hmm.
He's undercutting them so much that he reckons that for $19 million, you can use Falcon Heavy now. That's still way cheaper than a Heavy Delta launch.
Mm-hmm.
Probably a lot safer.
Well, they're both very good systems, very reliable. But the thing is, at the end of the day, it's how much less you pay means that you're going to get the business.
Yep. With efficiency and reliability.
Exactly. And for a long time, we were stuck with either using Ariane or we had Heavy Delta. Now Musk has brought his rockets into play, and he's helping in reality to fund further space exploration. Brilliant. I like it. And as I say, it's about Redshirt 3 says it's about 1/2 of a penny out of every dollar that goes to NASA. Why is Musk making money? He's resurfacing boosters and reusing them. He has a reusable launch system. And you know what? That is probably the greatest innovation ever. The fact that you can bring back part of your rocket, you can have it re-enter safely and controlled, then land it.
And reuse it.
Exactly. It is economic, and it is very planet friendly.
And cost effective.
Yep. You can see that my star pupils here.
I've got a similar thing. You mentioned BFR. How about a BFRS?
Okay, what's that? I'll buy it.
The last 2 letters would be red spot.
Oh, Jupiter time. Oh yeah,
it is
a thing.
Yeah, it's Jupiter time. Speaking of the great red spot, it's actually been changing more recently. It's actually getting smaller in diameter, but they have indications that it's actually getting taller, higher into the atmosphere. Let me put that link into our chat room here. There we go. Click that. So, yeah, it used to be like 3 times the size of the planet Earth. Now it's about 1.5 diameter size of the planet Earth. So definitely changing. And the wonder is it actually going to disappear? Well, if it keeps shrinking down, it definitely will disappear. They have recently discovered that those swirly clouds in the upper atmosphere of Jupiter really go much deeper than they thought. It was thought they were just a couple hundred miles of surface winds and stuff like that, but it's really that atmosphere is actually occurring a couple of thousand miles down into below the surface of Jupiter itself.
Well, if you think about it, the first confirmed sighting of the Great Red Spot was back in 1831. 1831.
Mm-hmm.
Now, researchers can't be certain whether early observers who saw a red spot on Jupiter were actually looking at the same storm.
Mm-hmm.
Now, keen observers have long been able to measure the size and drift of the Great Red Spot by fitting their telescopes with an eyepiece scored with crosshairs. And a continuous record of at least one observation of this kind per year dates back to 1878.
Well, some of it's related to several conditions on the Great Red Spot. Sun conditions, how much stuff is being kicked out by the sun has actually been shown to affect the Great Red Spot, made it darker, made it lighter. It just changes sometimes. Conditions, of course, 150 some years ago, it was a matter of telescope optics. Not as good as optics now. So what were they seeing? Were they seeing that much red spot, a little less detail when it was being observed 100 and some years ago? So it's hard to say, but definitely noticed that it's shrinking down a bit. So something for amateur astronomers to keep track of.
Well, the thing is, Marty, historical records indicate that the area of the spot grew temporarily back in the 1920s.
Mm-hmm.
So this could be just a fluctuation,
Yep.
seasonal fluctuation.
Definitely could be.
But as I say, only time's going to tell. It seems to be the mystery seems to be deepened as the iconic storm contracts. So researchers don't know whether the spot will shrink a bit more, then stabilize, or break apart completely.
Mm-hmm.
However, all we can simply say is Jupiter is a law unto itself. Its one great advantage is sometimes it will attract solar system debris into itself. Other times it will say, "Now I'm full up enough," and let's kick it towards us.
Mm-hmm.
Now, this is kind of related to the rockets things we were talking about. And Starstorm gave me this. This was actually in her fortune cookie, believe it or not.
Okay.
He can who thinks he can, and he can't who thinks he can't. This is also an indisputable law. So you're thinking about it. Musk, Bezos think they can, and they're doing it. People are poo-pooing and say they can't. Well, of course they're not going to do anything because they're already admitted defeat.
I think I can,
but before you've tried.
I think I can, but I still have not won the lottery yet.
True. Okay, talking of the solar system planets, new evidence in support of the existence of Planet 9. Okay, so as we all know, last year, the existence of an unknown planet in our solar system was announced. The hypothesis was subsequently called into question as biases in the observational data were detected. However, having said that, Spanish astronomers have now used a novel technique to analyze the orbits of the so-called extreme trans-Neptunian objects, and once again they point out there is something out there perturbing them. Now, keep in mind that planets this far out were all found by mathematics initially. So why can't mathematics now be sufficiently advanced to say there's another planet out there? Now, they believe this could be located between 300 to 400 times the Earth-Sun separation. Obviously, scientists are arguing about the existence of a ninth planet. I'm going to say this because I always say this. Pluto is always going to be my ninth planet. So this will be planet 10.
Agreed.
In the beginning of 2016, researchers from California Institute of Technology announced that they had evidence of the existence of this object roughly at a distance of 700 AU, or astronomical units, 700 times the Earth-Sun separation, and with a mass 10 times that of the Earth. Their calculations were motivated really by the peculiar distribution of orbits found for some TNOs in the Kuiper Belt, which apparently revealed the presence of Planet 9 or X in the confines of the solar system. Some French, Canadian and Hawaiian project scientists detected biases in their observational data for the orbits of the TNOs, which have been systematically directed towards the same regions of the sky, and considered that other groups, including the Caltech group, may be experiencing the same issues. The scientists say it's not necessary to propose the existence of a massive perturber, a Planet 9, to explain those observations, as they are compatible with a random distribution of orbits. However, two astronomers from the Complutense University of Madrid have applied a new technique, less exposed to observational bias, to study a special type of TNO, the extreme ones. They are located at average distances greater than 150 AU and never cross Neptune's orbit. For the first time, the distances from their nose to the sun have been analyzed, and the results published in the MRAS letters once again indicate there is a planet beyond Pluto. The nodes are at 2 points on which an orbit of an ENTO or any other celestial body crosses the plane of the solar system. So they are precise points where probability of interacting with other objects is the largest, and therefore at those points, the ENTOs may experience a drastic change in their orbits or collision. If there was nothing there to perturb them, these objects would be uniform distributed, as there's nothing for them to avoid. But if there's one or two perturbers, two situations may arise, according to Carlos de la Ferretti Marcos, one of the authors. One possibility is that the ENTOs are stable, which means they would have to have nodes well away from the path of any perturbers. But he adds, if they are unstable, then they will behave as comets that interact with Jupiter do, and that is tending to have one of the nodes close to the orbit of the hypothetical perturber. So they're using calculations and data mining. The astronomers from Spain have found that nodes of 28 ENTOs have been analyzed, and 24 extreme centaurs, all with average distances of 150 AU from the sun, are clustered in certain ranges of distances from the sun. Furthermore, if they have found that the correlation where none should exist. So I think that there may be something out there. What it is, I don't know. Is it a planet 3 times the size of the Earth? Possibly. And it's going to be very, very dim.
Question.
Mm-hmm.
Could it possibly be a rogue planet from another solar system?
Well, we know they exist.
They're definitely out there, but nothing close to the inner portion of the solar system, within the Kuiper belt, because it would be detected by now. So it could be something that would be pretty much on the far end of the Kuiper belt, but nothing on the near side of the Kuiper belt. We would be able to see it.
Yeah. So this is where they think that this planet is. So it's probably very, very dim,
Mm-hmm.
and it's gonna take great luck to find it. The fact that it's thought to be there mathematically. Well, we seem to remember that happening with a planet, don't we, Marty?
Mm-hmm.
And it was proven to exist. It was
Yep.
called George's planet initially, and of course, eventually it was confirmed, and the rest they say is history.
But they did think that Neptune was being perturbed, and then they found Pluto, but really found that Pluto's too small to perturb the orbit of Neptune. So that didn't pan out, even though all the predictions were there.
Aquafew wants to know, did a rogue planet twist up Uranus's rotation? Was Uranus a rogue planet? Well,
maybe not a rogue planet, but
No.
maybe just part of the initial blobs of everything that was inside the solar system back then. Obviously, you had the collision with the Earth. Mercury's got rather unusual composition. So there was just a lot of collisions during the beginning part of the solar system. But I don't know if we would call something that's like a partial planet a rogue planet. Definitely a lot of stuff that was flying around that was definitely not in standard orbits, because there were just too many collisions back then.
well, the other thing is, of course, it's more and more accepted that the gas giants formed in close to the sun,
Mm-hmm.
and the rockier planets formed in the outer solar system. But something disrupted the solar system and forced the gas giants out, and the rockier planets into the inner solar system. So, could it have been a rogue planet back in the early solar system? Who knows?
Or is just that the normal way of planet formation?
Exactly. So it could be that planets, gas giants, would migrate normally into the outer solar system.
Mm-hmm.
I mean, in the earlier days, and the rockier planets come in.
Yeah.
Certainly, it does look a bit difficult to have the gas giants forming further out,
Mm-hmm.
because they would, in order for the gas giants to form, they have to be able to take an awful lot of gas material
Mm-hmm.
in very, very quickly and very early.
Which
And in
should
the
be
outer part of the solar
which should be
system,
towards the center of the solar system.
yeah. So having a gas giant form in the outer solar system, I think, is very improbable.
Mm-hmm.
But I can accept rockier planets forming out there, yes,
Yep.
because there would be all that massive rock clumping together much easier further away from the sun.
We don't have to worry about Planet 9, but I really want to warn everybody about Plan 9 from outer space.
Oh, yes, that was a terrible film, wasn't it? Bela Lugosi's very last film, he died just after it, didn't he?
Or partway through it.
Yeah.
Did some preliminary, taping of it.
Yeah, he filmed some of it, and then he died, and
Mm-hmm.
everybody said that the film was cursed because of it.
Ceres. Let me put an article about the Dwarf Planet Ceres into our chat room. They've been discovering some changes in on things on the surface, especially in a crater called Julian Crater. They've been finding some, kind of been new water ices discovered kind of all over the dwarf planet, but now they've been finding some in this crater. Has actually been changing. So it's actually showing changes in notable or observable changes on features on Ceres itself.
Now, the interesting thing about it is with the combination of Ceres moving in closer to the sun in its orbit, along with seasonal change, that could be triggering the release of water vapor from the subsurface, which then condenses on the cold crater wall. This causes an increase in the amount of exposed ice that we're actually beginning to see. It could also, the warming could also be triggering landslides on the crater, which will also expose fresh ice patches. So what you've got here is a combination of chemical, geological, and geophysical observations, which the Dawn mission is producing to give us a comprehensive view of Ceres. Previous data has shown that the crust of Ceres is about 25 miles, 40 kilometers thick, and it is rich in water, salts, and possibly organics.
And Ceres is actually visible from the northern and southern hemisphere right now.
Yep.
Kind of between Gemini and Leo in Cancer the Crab area. You got to remember to look for it soon.
Yeah, one of the other stories I found, let me just get my mouse back. There we go. Now I can get back into the chat room. Okay, so spacecraft navigation. This is from Astronomy.com. Their news: future spacecraft can use pulsars to navigate. So what the researchers have recently proved is that spacecraft can use a narrow beam of radiation from pulsars to run a very accurate GPS-like navigation system. Now, this is a story from Amber Jorgensen. I'm just going to, it's got a pop-up come and get rid of it. So what they're saying is it could be possible for space missions to communicate data with Earth. The process is anything but fast. Now, Voyager 1, for example, takes about 19 hours to send a signal back to Earth, and that lag only increases as the spacecraft gets further away. For truly long-term deep space missions, the significant time it takes to send a signal isn't going to cut it. So the spacecraft will have to adjust its own trajectory without relying on ground navigation. That's where the pulsars come in. A group of NASA engineers recently showed that the fully autonomous space navigation is possible through the use of X-rays. Now, this is an interesting discovery. It could actually overhaul our entire approach to deep space travel. The X-ray guidance system was successfully tested during the Station Explorer for X-ray timing and navigation technology Sextant experiment. They used pulsars timed down to the millisecond. So the test spacecraft relied on X-rays to pinpoint the location of a space object moving at thousands of miles per hour. Now, this is a breakthrough demonstration because it means in future missions, as the spacecraft gets further away, it won't have to rely on the NASA Deep Space Network for its instructions about where to go. So at first, as it's the first attempt to demonstrate the technology, I'm being told to go look at the chat room. Excuse me for 1 second.
Mm-hmm. Well, could it tell you? It could tell you. Obviously, it tell itself where it's at.
Yeah.
But I don't know. Could it tell itself where to go? That would have to be pre-programmed.
Well, what they did to test the accuracy and ease of X-ray navigation in space, the Sextant experiment, which was funded by NASA Space Technology Mission Directorate, teamed up with the Neutron Star Interior Composition Explorer, NISA. Now, that is an external attached payload on the ISS. So what they're doing some very cool science, and they're using the ISS as a platform to execute it, which in turn enables X-ray navigation. So NISA has studied various aspects of neutron stars since its ISS deployment back in 2017 in June, and it's currently using its 52 X-ray telescopes. 52.
That's a lot.
It's a lot. And the silicon rift detectors to study the radiation that pulsars emit into the electromagnetic spectrum. Pulsar radiation comes to us as very narrow beams of light, which then flash when they speed past us. It's very similar to the flashes of light emitted from a lighthouse. Mm-hmm. Yes, I did see that reference in the chat room. Their pulsations are also predictable in nature, enabling them to serve as highly meticulous timing agents compatible to the atomic clock signals that GPS use. In fact, they are that predictable that the arrival times for beats of a millisecond pulsars can be predicted years into the future, with time accuracies in microseconds.
That's cool.
It's very good. Yeah, it's very cool. So what the Sextant experiment did, they chose 4 millisecond pulsar targets and positioned NISA so it could detect X-rays within the target's narrow beams of light. To obtain timing data, they collected 78 measurements over a 2-day period. They were then fed into Sextant's onboard algorithms, creating a navigational solution that disclosed NISA's orbital position. That was then compared to NISA's onboard GPS-derived location. So when you think about it, NASA travels aboard the ISS at about 17,500 miles a second relative to the Earth. So the study aimed to pinpoint the location to within a 10-mile radius. They were
successful.
They were given 2 weeks to locate the craft with such accuracy, but it was able to detect its location within the given radius after only 8 hours.
Of being up and running?
Of the project up and running, yeah. So
wow.
what they've done, Starstorm, is they've actually proven that X-ray navigation is possible. And now they're going to start work on updating and improving the software in the anticipation of an additional experiment later in 2018. They're going to work towards narrowing the instrument size, reducing the power requirements, and improving sensitivity. The end goal, of course, is to make X-ray navigation technology readily available for all space missions. So that would give them an autonomous navigation without ground communication. So if the space probe needed to change its attitude towards the Earth for a signal, given to where it was going, it would be able to do it, and it would be able to do it without human intervention.
Space autopilot.
Autopilot, exactly.
Now, is that for a probe within our solar system or beyond our solar system?
At the moment that they're talking of doing, it could enhance deep space navigation anywhere within the solar system and eventually beyond.
Okay. Yeah. Doing navigation beyond our solar system, just out through the galaxy, is actually very, very difficult. It's kind of like, finding our sun in the galaxy. If you just come upon our galaxy and actually finding our sun, is kind of like going out on the beach, pick up 1 grain of sand, drop it, walk away 10 feet, come back and try to find it again. Almost impossible. That's how difficult it is to pick out our sun within the Milky Way galaxy if you're just coming into the galaxy. So, galactic navigation is very, very difficult. You'd be surprised how hard it would be to find our sun if you just came into the Milky Way. If you've left the Milky Way and came back to the Milky Way, you'd have a very, very difficult time of actually finding our own sun again.
I'm reading the chat room, and somebody's saying, so we need to build a wall that goes up to the stars, right? Not going to happen. A Dyson sphere armed with lasers or a big bubble. And one person has said, all we need now is for Google Maps to send the cars to space to map the solar system. You know what? They probably do it with something like Orion.
A couple ways I've thought about galactic navigation as well. For one thing, just the general plane of the Milky Way galaxy, and then you could use known galaxies like Andromeda Galaxy, M82, and as many as you can. And basically, you kind of triangulate your position, so that will get you at least close to the area of where the sun's located within the Milky Way galaxy. Another way is with major supernovas like 1987A. If you think about 1987A, its light, hit the Earth in 1987, and from that point, it's been basically radiating out in an arc. So right now, you can see supernova 1987 30 light years away from the Earth.
Well, how about using CFIDs?
Well, you need a unique event in order to be able to know when that was going to occur. Like a supernova.
I've been asked by our main mission to remind you that there is the Nick Howes interview with me after the show,
which is coming up soon.
Which is coming up very, very soon, because we're now into the last 45 seconds of the show.
Indeed. So everybody stay tuned after our program here and listen to that interview. And we also have a brand new Talking Space coming up after the Event Horizon. So it's time for us to get out of here.
Okay, this is the away team to the USS Miranda. Captain Savick, we're ready to come home. Have a great night, everybody. Thanks for being here. Be seeing you, and look up.
Appreciate y'all listening.
Good night.
Appreciate everybody in our chat room tonight. Thanks very much. And don't forget, we got some more great programming coming up after the Event Horizon. Good night, all.
Good night.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true. Every little bit counts.
AFM. There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.